Hello and welcome to Robots, Toy or Tool. Explore the power of robotics to inspire and equip the next generation. My name's Adam Watson.
My name's Jarrod Burke, and we'll also be joined today by Kath Lollback, and we're all STEM T4L leaders. So today we'd like to acknowledge the traditional custodians of the land on which we meet today. We acknowledge the role of elders past and present and future, and the importance of observing the cultures, customs and traditions of Aboriginal Australia.
Hi, I'm Kath Lollback and I'm from Kempsey on the Mid-North Coast, and this is very exciting to be a part of EduTech. Today I'm here with Adam and Jarrod, and we're going to be talking about robots, toy or tool. We're going to explore the power of robotics to inspire and equip the next generation. To show you the value of robotics in education, Adam, Jarrod and I thought it would be fun for each of us to look at different robotics kits. So we'll be able to give you a bit of a taste tester and to demonstrate how user-friendly this technology is and explore some practical examples of how this can be used in real, authentic learning experiences that help develop those future-focused skills. So we'll be looking at LEGO Mindstorms EV3, Spike Prime, and WeDo 2.0. And I'm lucky enough to be first up. So let's go and have a look at LEGO WeDo 2.0. This kit includes a smart hub with 2 ports for both input and output. It includes a motor, 2 sensors, a motion and a tilt sensor, and an additional sound sensor built into the software. It's accompanied by visual programming software, and it's aimed at stage 1 through to 3. The blue tub contains a massive assortment of 280 toy-sized pieces in the kit. Although it may look like students are playing with a toy, this robotic kit actually allows students to become creators. Using the kit's contents, they problem solve and develop solutions. So the only limitations are the ones from your own imagination. One of the best ways for an educator to incorporate robotics into teaching and learning is through project-based learning challenges. We'd like to share with you a project-based learning challenge called Smart Car. These challenges are intended to be scaffolded against numerous KLAs and not taught in isolation. This particular challenge is scaffolded against science and technology, maths, literacy, and numeracy. Over a term, teachers would cover with students a hook event, 3 mini challenges, and a main challenge. Today, Jarrod, Adam, and I are going to be using each kit to come up with a different solution to the same problem. So the big question for students is where to go when they're establishing ideas for designing their prototype. For me, it's to the media library included in the WeDo software. Throughout the teaching and learning process, students may create a labelled blueprint of their design before starting to build. I'm going to use the steering design. I can modify this design to include sensors like a smart car. Jarrod, Adam, I've got to say I've started drafting my design and it's pretty exciting. So the next thing that we need to look at with WeDo 2.0 is the programming. This can be very intimidating for teachers and students alike. So let's go and have a look at that software. This is the landing page for our software. The software is available for PC or laptops and as an app. As a teacher, I like to have my screen open on the interactive whiteboard during Mini Challenge 1 when students are being introduced to the technology. You can see the green ribbon below where it says My Projects. We simply click on the green and white plus to open and begin a new project. You can see when we open a project that an event block is already on the screen. At the bottom of the screen, you can see there's a colourful ribbon of blocks. We can drag this with a mouse or on a touch screen with our fingers. The green blocks are our action blocks. I'm going to drag up the very first green block, which is a motor. It's automatically populated with the number 8 underneath. This is the speed of the motor. If I want to change the speed of the motor, I simply click on the 8 and change this by pressing the numbers on the ribbon below. I'm going to make it go a speed of 2. I can also change the direction that the motor is going. There are 2 direction blocks. However, we can just use one of those direction blocks and click on it to change that direction. If I don't want a block, I can drag this block down to the ribbon and let go. This block is for the LEDs. If I click on the one, you can see I get a selection of colours to change on my LED on the Smart Hub. I'm going to make the colour of my LED orange. At the moment, my program says when start is pressed, run the motor at a speed of 2 to the left, change the colour to orange, and then I'm going to get the motor to stop. This is a simple algorithm. If you recall, when I told you about my design idea earlier, I want to include a sensor for my smart car so that it can detect motion. So I'll need to include this in my program. I'm going to create an if statement so that when it detects an object, the program changes. If statements are a part of this Stage 2 curriculum. In my flow control blocks, that's the yellow blocks, you'll find a wait block that looks like an hourglass. You'll also find blocks for the sensors. The motion sensor is orange. I'm going to connect this underneath the wait block. I'm going to remove my stop. And so currently my program says when start is pressed, run the motor over a speed of 2 to the left, change the colour of the LED on the hub to orange, and then if the motion sensor detects an object, I'm going to get the motor to change direction. So I've got one going left and one going right. And I'm going to get that motor to run for 1.5 seconds. And then I'm going to get it to stop. So now I have my algorithm which says when start is pressed, run the motor for a speed of 2 to the left, change the LED on the hub to orange. If the motion sensor is detected, then change direction to right and run for 1.5 seconds and stop. One of the most important things once you've created your program is to download it to your device and test, modify and test, a continuous cycle until you've got it exactly how you want it. Now to unveil my smart car, drum roll. Okie dokie, excitement, excitement. This is my smart car. And as you can see, we have the steering to allow the smart car to turn. We also have a sensor, a motion sensor attached to detect objects in its path. And of course, the smart car has character. And I'll play you a video of how it goes when I download the program. But first, we need to download the program. So let's have a look at how we do that. Okay, to download your program, first thing you need to do is open up the Bluetooth tab in the top right-hand corner, and it's blue. When we click on this Bluetooth tab, it prompts us to press the green button on our hub. We press the button and a light flashes intermittently. So I press the green button and I can see my device, Snail, and I click on Snail and you can see that this turns a solid green. This tells me that my device is connected to the software. So I can close this, and now when I press play, my program will run. But what I might do, because I want to modify this a little bit more, I want this to continually happen. So I'm going to get this to work in a loop so that it continually moves around, moves forward, and when it detects motion, then it actually changes direction and continues on for 1.5 seconds and stops, and then starts the cycle again. So let's have a look and download the program by pressing the start button. Okay, here we have my smart car on my kitchen floor, ready to go. You can see that the light is blue, and I'm going to press play. And you can see it detects my hand and changes direction. Let's see if it runs into the stove. Or changes direction. Fantastic. Hey, thanks for tuning in. That was lots of fun. And I'm going to hand you over to Adam and Jarrod, and they're going to take you through Spike Prime and Lego Mindstorms EV3. Thanks.
All right, so we've heard from Kath Lollback in her overview of the Lego 2.0 WeDo kit and some of the ways that can be used in the classroom to make engaging projects for students. She's covered that self-driving car project, which is always a big winner in the primary classroom, isn't it? When we make links to the outside world with self-driving vehicles and things like that. Would
Absolutely,
you agree?
it's a very relatable project to build in the classroom.
Right, and you know, the Lego WeDo 2.0 is a nice, simple kit to get started with in the sort of primary, middle primary kind of setting there. We're going to take a quick look now at the Lego Spike Prime kit, which is sort of more suited to that middle range where you've got that upper primary into lower secondary kind of year groups. So let's dig in and take a look at what's inside this kit, some of the sensors and the motors and the brick and stuff. First thing you'll notice about this kit is it's got this awesome white lid with the gutter around it. And I don't know about you, Jarrod, but when I build my Lego kits with my kids in the class, it's all about that classroom management with the Lego pieces, isn't it? So they don't go flying all over the place.
Always tell my students to build on the lid.
Build on the lid. We've also seen hula hoops, stuff like that used as a classroom management tool with Lego, so that's always a big hit. You get your card there with your instructions, your overview of what's inside the kit. Some of the changes that are made to this, this new kit as it's been released is they've given us two little building trays there, or sorting trays, so that we can have them spread out on the table and we're not sort of like limited to one big thing that can be a bit cumbersome. And inside we've got some brand new sensors that I really am excited to show you because they're a different design than what's come before and what's in the EV3.
One of the things I really like about the Spike Prime is that it's taken all the great things about the WeDo and some of the really cool functionality of the EV3 and packed it all into this good sort of middle schooling type robotics kit. It's really good.
Yeah, and that's not to say that this thing isn't a powerful kit either, because one of the advantages of these new sensors is that they've added some extra functionality in terms of this touch sensor, for example, being an analog touch sensor that you can use that will detect force being applied in like a gradient. So it will detect the difference between a hard press, a soft press, and things like that. So you get a touch sensor in the kit. You get an ultrasonic ranger in the kit as well. Now they have one of these in the EV3. This is not in the Lego WeDo 2.0, but this is a really interesting sensor because we can make connections with the outside world with this sensor, right? With the ultrasonic ranger. I mean, where do we see stuff like that?
You probably see something like, the kids can relate to it, as in when you walk into the supermarket and the doors automatically open. So a sensor to detect movement.
Yeah, detect movement, detect motion, things like that. Obviously it's an ultrasonic ranger and it works on the concept of ultrasound, the same way that an ultrasound machine at the hospital works as well. So with Lego, it's all about having fun and being engaged with the robotics, but it's also about making that meaningful learning and making connections to the outside world so students can engage with, you know, industry and what's happening outside, right?
Absolutely. When you talk in terms of STEM, no better, well, it's really one of its great benefits is its ability to engineer a solution. And it could be anything. And you really want your students to be able to branch out, and everyone should be able to make their own thing, so you get a lot of diversity in your lesson.
Totally. You also get the color sensor. This is a really, really sensitive sensor, actually. I've noticed they've seemed to make some improvements to this color sensor.
Definitely picks up a broad range of colors, doesn't it?
Yeah, totally. And you know, they give you a bunch of these different colored traditional Lego bricks in the kit as well, which are very handy. So you can engage with your colourful projects there straight away. So you get your touch sensor, ultrasonic ranger, colour sensor, and you get some motors in here as well. So we've got 2 of the medium-sized motors there that you'd use for driving, typically with a driving vehicle, like so. And you know, you get your right-angled large motor as well. So 3 motors, 3 sensors. So it's a bigger kit already than the WeDo 2.0, and you can see that it's got a lot more functionality in terms of the hardware itself. But the brick as well has got some sort of improvements made there too. It's got an interesting display that lights up, can display numbers, text, things like that. It's got a speaker.
It's a little bit like the micro bit in that respect, isn't it?
Oh, totally. You know, it's got quite a lot of functionality built into the brick. Now, in the interest of time, we don't have time to go really deep into this stuff today, but we certainly want to give you a good overview anyway. So one thing that I'm going to show you now with this particular kit that I love about it is the fact that you can just plug stuff in and make it work straight away without needing to do any coding. Now, as a classroom teacher, and Jarrod being a classroom teacher, I'm sure you would agree that that instant gratification is important for students in the classroom.
Absolutely. It sort of overcomes that hurdle of if someone's struggling a little bit with the coding aspect, being able to plug and play is a really great way to sort of get these projects off the ground.
Totally. And I'm just going to go ahead and plug in one of the motors into one side of the brick here. I'm not even picking what I'm plugging in here, and I'm going to plug in a sensor into the other side of that brick in the corresponding socket there. I'm going to power this brick straight up like so, and we will see just how easy it is to make something move straight away with the Spike Prime.
Let's pop that on there so we can detect the movement a little bit better.
Very good. So there's my motor plugged into one side, my sensor plugged into the other side, and straight away I can press this arrow, and it will operate into that mode like so, which will give me a visual indicator that the sensor and the motor are both plugged in to the brick, and it makes that connection between the two, and you can see straight away my sensor is operating my motor with no coding required whatsoever. Now this is something cool about this sensor, right? Being a gradient of force is that I can use it to control my motor like a throttle on a car.
Absolutely.
So a short, soft press will operate my motor at a slow speed there, and you know, I can rev that thing up with a harder press like so, and I can hold it on full throttle, and I can do a big burnout with my Lego Spike Prime, Jarrod.
Absolutely. And the kids will always want to figure out how fast it goes. And that's quite often one of the first challenges I like to set my class is, how fast can you make it go? And I definitely will hook the interest of your students into that.
It's always about full throttle, isn't it? When we give those students the option of coding our projects to move at 50% throttle or 100% throttle or whatever, what do you think they usually go for?
Yeah, absolutely. They like to find the biggest number they can to make it go as fast as possible.
Yeah. And I mean, here we have another sensor here. Now, I've got these motors connected to the corresponding ports there. I've got my sensor plugged into the other side now. This is the color sensor, and it's the same thing. You can see here, I'm going to fire this up, try not to make it run off the table, but if I move my hand in front of that motor, that sensor rather, you can see there, same thing. Now this works on the concept of distance. You know, it's a reflected light intensity sensor. The closer my hand gets, the darker that sensor appears to receive the light, and the more it will control the throttle. And I can keep plugging in more motors and sensors, and I can add them onto the brick like that, and basically create a moving project with no coding whatsoever. Instant gratification for students, really interesting feature.
Absolutely. And so for the 3 different model types of Lego that we're showcasing today, we've all chosen a driving robot base. So when you're teaching with Lego in any sort of shape or form, your first lessons are always around following the built-in instructions. Follow that very guided approach. So we recommend doing that. Build that one straight out of the instructions, but then from there, get your students to modify that base model. That'll be their first step into advancing into doing what we call an open build, which is not following any instructions, and they can just build whatever they like. So that's why it's a great stepping stone. So Adam over here has got his Spike driving base, and we'll talk about in a moment about what he can add to that and how to code it.
Yeah, totally. One thing I want to show you just before I pack this up, because I've got my driving base there, is the last thing are these large frames. Now the large frames and the large base plates, they're really good too because, you know, as we know, being in the classroom, we want to have students up and building quickly. We want them to be engaging with stuff like on the fly, not spending 3 hours building a model or longer because they're not familiar with the Lego or they're not familiar with it. So, you know, you've got larger frames, larger base plates, quick, easy, effective builds with the Spike Prime, and that's a new feature too. I think that's really cool. So that's the overview of the kit just there. We'll have a quick look at this driving base now. Now all I did with this driving base was followed one of the builds that's in the Spike Prime app. So what I'm going to do is I'm going to show you the Spike Prime app now and talk to you a little bit about that app and about some of the coding that can go into the Spike Prime kit. So there's two different types of coding. You've got visual code and you've also got Python, right, which is the text-based language.
Absolutely. So it gives you that versatility between primary and high school, and it also builds a nice little bridge between learning those two different approaches to coding. So the visual, when you look from a stage 2, stage 3 point of view, students need to learn a visual coding language, but the Spike Prime also supports that script-based Python language. So Adam's going to open up the app now and show you where he found those instructions to build his driving base.
So let's take a look at the Spike Prime app now and the coding interface that goes behind all the builds and the stuff that we create with the Spike Prime.
Something you would have seen in those WeDo videos is the really great user interface, which is something they've brought over to the Spike Prime.
Yeah, absolutely. You know, what I like about this app as well is that it's got, you know, units of work there that you can engage with straight away. So the unit plans are really good to pick up from if you're not sure where to start. You know, the invention squad's really neat. If you're into the first Lego League competition side of things with Lego there, they've got some competition ready builds for you as well. You know, but there are some simple builds and some more advanced builds as well in the building instructions page, and that's where I got the instructions to build my driving base from. So just here we've got the driving base 1 instructions, you know, and it's like very much the Lego that we know and love in terms of the simplicity of the build. So you've got that really pictorial kind of building instructions there, overcoming language barriers and maintaining that really simple low on-ramp for students, which is good. You know, and it's a relatively simple build to get your driving base up and running. And in this case, it's saying that we will put a motor on the front for our driving base, but I've chosen to put a sensor on because I want to demonstrate some coding with the Spike Prime, and I want to follow on from the Kath Lollback's example of the wonderful self-driving car and show you some of the differences between the two kits with a project like that.
So there's a whole bunch of both simple and advanced builds that you can do from the project unit library, which, as I said, is a really great place to start to learn the mechanics of how to use the Lego. But once you become more confident, take one of those and modify it before being able to do a build using no instructions at all. That would be your final outcome using these Lego kits.
You know, I mean, like just looking at this CNC machine build here, Jarrod, you know, me as a secondary industrial technology teacher,
Absolutely.
That really interests me because I love the idea of 3D modeling and CNC machining and all that stuff in the woodwork and metalwork rooms, and being able to like access that kind of passion and that kind of knowledge and all of that industrial kind of connections with the Lego kit is really cool, don't you
it's
reckon?
really cool. And like while we're showcasing driving robots today, they're a great place to start, but there are so many things you can engineer using Lego and robotics, and this showcases them really nicely in the app. Yeah,
totally. And you know, as you can see, the Spike Prime is certainly more of an engineering focused kit. It's more of a kind of a, you know, a STEM and engineering kind of focus there.
Cool.
So
right, let's jump into some coding.
Yeah, let's have a look at the coding. All right, so I'm going to start this off again actually because I'm wanting to start from scratch and I want to show you how easy it is to get started with the coding. I'm going to choose a word blocks code for today for simplicity's sake if you're watching along, but you can engage with Python there. So you've obviously got that option for text code as well, which is important if you're in a secondary environment and you need to teach fluency in a general purpose code language. So what I'm going to do is I'm going to create a self-driving robot that uses the ultrasonic ranger sensor to pick up obstacles in front, and then I want this to be a point of difference from my WeDo 2.0 car because I want it to keep track of how many obstacles it's picking up. Now I'm going to make a connection here for my students between this self-driving car and a Roomba vacuum cleaner, right?
Absolutely,
now,
yes.
As we think about a Roomba vacuum cleaner, self-driving vacuum cleaner, it's going to hit a table leg if it gets stuck under your table, and it's only going to hit so many table legs before it realizes it's really stuck.
Absolutely.
Right? And you don't want it to be hitting table legs all day long, do you? You want it to hit a couple of table legs and then probably go into standby mode so that it's not constantly hitting table legs while you're at work all day. So we need to keep track.
Give it a give. Also to turn not just left but right. Quite often in your algorithm you get it to turn a certain direction. By using that variable to keep track of what objects it hits, you can change the direction of your robot and get it to move in different ways.
So I'm going to create a new variable here, and I'm going to call that variable obstacle counter, because I want to keep track of how many times that I'm actually hitting an obstacle. So when my program starts, set that variable to 0. Now I'm going to set some movement speed here. So I'm going to set the movement speed to, let's call it 20% for today, because we are demonstrating on a tabletop, right, Mr. Burke? We don't want this thing to fly off the table and, cause a total disaster. And we're going to identify the movement motors here as being plugged into the correct ports. Because this is a robot, we need to tell it everything. This is something that's, again, something so important to get across to students when we're doing robotics, is that we need to make sure that we're really explicit with our language, don't we?
Absolutely. Computers do need to be told every little step along the way. So this is that part of that on start, that getting your robot ready to move before Adam gives it any instructions to do so.
Yep, and then we've got this forever loop here that we're going to enter into. So once we've defined all of those things, we can then sort of go into this forever loop that's going to run our code, repeating over and over and over. And I want to display on the top of my actual screen there the variable that is that's going to be my obstacle counter number. So it's going to display that number so I can tell how many times it's hit an obstacle.
That's a really good thing to do in any sort of coding, is what we call that a flag. So when we're debugging our code to make sure it's working properly, the fact that you can get that variable count to display on its back is a perfect way to keep track of what it's doing.
Totally. And then what I've got here is then an instruction to start moving. And I'm going to run now what's called a conditional statement. So do you want to explain what a conditional statement or a branch is?
Absolutely.
Jarrod?
Essentially, a conditional statement is a decision in your code. So when you're talking from all the way even down in from stage 1, you need to include one decision in your algorithm. From stage 2 and 3 onwards, and into stage 4 in high school, it brings in the term of branching. And branching is just simply multiple decisions in your code. So right now, Adam has added a decision into his code to say if his sensor detects an object, it wants it to do something else. So adding decisions in your code is a really important programming concept to understand to build your skills in this area.
Yeah, that's right. And so what I want it to do is I want it to be looking for an obstacle, which it's doing here with this if statement. So if we just recap what this is, when the program starts, set the variable to 0, start moving after it's identified its motors, start moving and display the number of obstacles it's hit. And while it's moving, I want it to check if there's an obstacle in front. And if there is an obstacle in front, then it's time to make a decision, right?
Absolutely. So it's checked. That's a first decision, and we're going to make another decision now based on what we got from that first decision. So if there's an obstacle in front, let's do another decision now. And it's going to decide which direction it's going to go in.
Right. And what I'm going to do here is I'm going to put a parameter in that says if you've hit a set amount of obstacles, then make another decision, right? Otherwise, just keep moving in the direction that we specify. So we're actually putting a decision in here that's within a decision, right? So what do we call that? There's a technical term for that. It's nesting.
Called nesting. Yeah.
Right, nesting
Nested
a loop.
decisions, yeah.
Right, now, so do you want to talk a little bit about the kind of links to curriculum that we can make with this robot that sets it apart from the WeDo 2.0 in terms of that coding and variables?
Well, yeah, absolutely, because you can add more of those decisions and get more sensors to get I guess, inform the rest of your algorithm. So there's lots of different ways. So when you're talking up until a stage 3, we're also building in what we call iterations. So every time this program loops around, something is changing or something is being checked. which talks a lot to that decision making. So by checking something, it's checking to see whether something has happened. One concept that we didn't mention before is something called a variable. Now, a variable is like a container that stores information, and that information can change throughout the program being run. So understanding those concepts within the code of branching, which is multiple decisions, iterations, which is looping code, where each time it loops something changes or something is being checked, and also that we're using a visual programming language that we're demonstrating today. And you'll find them all in the science and technology syllabus. All right, we might need to, just while Adam adds those last little bits of code in there before we jump into the EV3, which is the big brother of these different kits.
How about this?
Yeah.
Why don't I finish my coding here?
Sure.
And while I'm finishing this coding off and getting ready for a demonstration of what this looks like,
Yeah.
why don't you introduce people to some of the nuances of the EV3 kit and some of the
Absolutely.
sensors and how they're a bit different?
Absolutely, what a great idea. All right, so the EV3 kit. The EV3 is, I'm just going to skip forward here a little bit. The LEGO EV3 is kind of like the big brother of all these kits. So hopefully, as you can see on the screen now, this one has 8 ports, 4 input and 4 outputs. If you see here, I'll show you in a moment. It also has 4 different sensor types, as opposed to only 3 in the Spike Prime. But you can also code these from using visual coding language, but you can also use JavaScript and Python, which then meets a greater variety of needs. This one's aimed at sort of stage 3 and above, but there's no reason why you can't use it with the younger stages, but it is a little bit more of an advanced robot, and it looks physically a little bit more intricate with all the wires and everything going everywhere. So I'm going to open up a LEGO EV3 box now, and just to highlight some of the differences between the other kits. So in this particular kit, we've got one large tray with all your different pieces in there. It's really important. I always like to remind the kids, careful not to kick that over, because you'll spend
classroom management.
Absolutely, you'll spend
all
half
about
the
that
lesson picking
classroom
up all the
management.
bits and not actually doing your build. So you've got your large red tray with all the bits, and underneath is where you'll find your wheels, your Lego brick, and all your sensors. Now, in my demonstration one here today, I'm using my Lego brick here, and I've attached the ultrasonic sensor to the front, much like this sensor here on Adam's Spike Prime. It looks a little bit like this using the EV3. I've got the 2 large motors that I'm using for wheels on the bottom, and I've also got the medium motor here plugged in the middle, which controls the movement of the head. A few other sensors that you'll see in this kit are the touch sensors, a little bit like the force sensor that we saw with the Spike Prime. They're push sensitive. They don't quite have the difference in push pressure, but they will detect movement there. And you also get a gyro sensor, which it can sort of track its movements, and you can use that to inform your code. And there is one other sensor which I have in the other box, which is a color sensor, which can detect the different colors, reflected light intensity, as well as an ambient light intensity. Now, one thing with the LEGO EV3 is it comes with this book. You'll find, because the EV3's been out a little bit longer, it is a pretty hefty build. A lot of teachers will give this to their students as they start building. You will be there a long time building this one.
Are there simpler ways to get started with the EV3? I mean, that's the beauty of the other kits, right? It's that instant gratification, straight up and running type thing. That is a very comprehensive resource. Is there a better way?
Well, there are some simpler building instructions available out there. I might pop up on the screen in a moment. Before I go into that, there are 3 different ways of coding it. There is a Mindstorm app. You can use Microsoft Make code to do it in blocks in JavaScript, and then you can also use Visual Studio to do MicroPython.
Wow, so what you're saying is this is actually a really super in-depth, foray into coding, isn't it? As well as being an engineering kit, it's got a great focus on engineering, obviously, with the amount of hardware. It's also got some really good options for engaging with text code. Right, as well.
Absolutely, yeah. It's it can be very, very in-depth, and a lot of different areas and directions you can take it in. On the screen, I'll pop up just now, there is you can scan that QR code to possibly take you to, there's Damien Key's got a really great website with some quick, simple builds. So if you follow the book, I've heard sometimes this can take maybe 2 hours to build, but if using one of those links there, people have created some much more simplified builds where you can build that basic driving do the driving base within maybe 10 to 15 minutes.
And then you can
Lesson
build
going.
on top of that, can't you, as well? Like that driving base is a great foundational place to start.
Absolutely.
You can add more sensors to it, can't you? You can add more motors onto the top and have grappling arms or anything that you want for your projects, right?
Very much so. The engineering possibilities are limitless. With this example robot that I built today, I've added, this is the base from that quick build, and I've added an ultrasonic sensor to the front, and I've used a motor so this robot is going to look left and right to check for obstacles around him when we make the coding decisions for him. But just before we jump into the coding for the EV3, I think Adam's finished with his Spike Prime coding, and we can demonstrate how that works.
Absolutely, thank you. Yes, thank you for your patience. It's one of those things, coding, isn't it? It's an in-depth sort of venture for a lot of teachers, which is why it's great to have something that's a simple visual block-based editor to start with, right? And then we can move from there into text. And well, once we develop that foundational understanding of how the blocks work, right? That's the power of the visual coding. So I have finished my code. Now I just want to walk you through this really quick. So we'll get my screen up in focus again, and we'll just go through what these blocks actually mean. And then we'll have a look at what this looks like on the table with the Spike Prime. So my blocks are basically saying, when the program starts, set my obstacle counter variable to 0, set the movement speed to 20% of the throttle, so it's not going to be going at full ball straight away, and identify the motors as being plugged into ports C and D. Right, pretty straightforward stuff. Then go into a forever loop that's constantly repeating. Show the number of obstacles that you've come in contact with on the top of the block, and start moving. And then once you're moving, do these checks. So it says that if is the branching statement, right, that we spoke about before. So make a decision. If that sensor that's plugged into port A detects an obstacle that's closer than 20 centimeters, then stop moving and do this stuff that's inside. Otherwise, simply skip past that and continue moving, because you're in a forever loop. So you'll be moving forever and ever unless you see something, right? But if you do see something, then it's time to keep count and it's time to make a decision about what to do next. So you can see there, you're going to either turn right and then change that obstacle counter by +1. So you're going to add something to your memory. So you're going to have then a variable of 1 obstacle that I've come in contact with. And keep moving. But then if you come across another obstacle, well, do that same thing again, right? But then you're also going to check in that green block there how many obstacles you've come into contact with, right? Now, if you've come into contact with more than 2, well then do that stuff that's inside that particular branch, right? Which is go backwards and turn left instead of turn right. Now that's an important concept to get across to students, don't you think?
Absolutely.
When we are talking about robotics and developing a little bit of intelligence in our robotic systems, we don't want them to just keep doing the same thing over and over, like banging your head against a brick wall. We want them to actually be able to figure out their own problems. Now that we've explained that, Jarrod, let's have a look at what that looks like with a Spike Prime.
Absolutely. Maybe we can point it here at this poster and get it to drive towards it, and then we'll move the piece of paper around here on the table to act like different obstacles, and we can have a look at how many things it bumps into and what decisions it makes when it comes in contact.
So let's turn him on. Now, press the power button there. He's going to fire up, and there we go.
We need to download our code.
Oh, the lovely love heart. Oh yeah, sorry, I forgot to mention that's the crucial part of today's lesson, isn't it? Yeah. Don't forget to download your code to your block before you start doing that, and you do that with the simple play button that's in the bottom right-hand corner of the screen. I will show you that before we leave off this section as well, so we will go back and have a look at that. But we've got the code downloaded there, and I'm going to scroll across to my program 0 and press the start button to kick it off. Remember, he's going to keep count. You won't be able to see because it will be on the top of the brick, but you get the idea. So
he's just to take
obstacle that's less than 20. Oh, that's another obstacle. So that's turning again in the same direction. There we go. He's turning again.
Each time, so it now says 3.
Now he turns in the other direction and goes
and then he goes back to the start of his loop and he continues to do the same thing. So
There we
every
go.
third object that he comes in contact with, he's going to do a different turn to the original.
Oh, there he goes. Getting dangerously close to the edge of the table there, Jarrod.
Absolutely, playing with fire. All
Yeah.
right, maybe we'll stop him there.
I know, right? We should put an altitude detector on him, don't you think, as well?
Absolutely.
So he falls off the table.
To see
and
how he
can-
plummets.
Maybe a parachute next time?
Yeah, absolutely.
Anything's possible. It's
Anything's
Lego, people.
possible.
So that is what our code looks like in practice. I mean, it looks simple, doesn't it?
It does.
But
But it takes quite a few, you need to keep working at this and chip away and have a look at it and get used to what the different sensors do and how you would code them and get them to interact with different objects.
you know, the thing is as well, kids will play around with this, won't they? They'll add more stuff. They'll prototype things.
Yeah.
And that's the idea. It's a design thinking process, isn't it?
Absolutely.
And this is the tool that you can continue to build on top of, literally, and add more things, make your machine better performing based on the tests that you do, because you won't always get it right the first time.
No, absolutely, and it's that repetition, as you said, of that cycle of go back and make changes and do it again. If that doesn't work, make more changes and do it again. And documenting that process can really help.
All right, I'm excited to see this thing. This
Yeah.
is like an absolute machine.
So this is kind of like a step up from, as we were explaining before, from the Spike Prime. And this one's been around a little bit longer, so the coding interface does look a lot different. So as I said before, this robot drives along and he will detect an object just like the Spike did, except I've added the fact he's got an oscillating head. He's going to look left and right to detect objects left around him and make an informed decision about where to go to next. So I guess the important thing, I'm going to jump into my slide deck really quick and show you here. I just want to just highlight some information about what I added to that base build. So I mentioned that base build, that Riley Rover base build before, and this is something that I mocked up myself. It was just I engineered a very simple mechanism there with 2 gears turning, perpendicular to each other to make this head turn. So it doesn't have to look like this, but feel free to engineer your own solution to meet that outcome.
Wow, that's a mouthful, isn't it?
It is.
Gearboxes, engaging with that type of stuff, you know,
Yeah.
that's an engineering studies kind of thing. I know that for a fact as a TAS teacher, that we look at mechanisms and we look at those types of systems and how they can be implemented with machines.
And so much maths involved in this. It's a really great way to integrate this into your maths curriculum too.
Totally.
I'm just going to jump out of this and I'm going to open up the Lego Mindstorms coding space, and I want to show you what that looks like to code this today. All right, I've got my Lego coding suite open right now, and this is the block coding Lego app. And it looks a lot different to what we've just seen using the Lego Spike Prime coding space. So it's a visual coding language. But it drags in these blocks and it takes out a lot of that basic literacy to make it a bit more universal, works across multiple language spaces. So to explain what my code does here, it's a little bit less intuitive, I guess you could say, than the Spike Prime. You really need to understand what those little, all the different, the little icons mean on all the different blocks. And I'll code this for you in a minute. But essentially, this robot, the way I've coded it is it's got 2 variables. It's going to read distance left and distance right. It's going to drive until it sees an object, have a look, measure those distances, and then it's going to move away from the closest object.
So you're still traveling along the same line then, no pun intended, in terms of the purpose of this code, right?
Absolutely.
Drive along, look for an obstacle, and make a decision, yeah?
Yeah, absolutely, that's it. So I'm going to jump into a fresh coding space now, and I'll show you how I put this together. So from my play button, exactly the same as the other 2 Lego products, I'm going to get my robot simply to begin by driving forward and seeing an object. This is the similar code as to what Adam showed in Spike Prime. So to begin, I'm going to drag in a move steering block. I'm going to set it now to just being on. This is driving with no restrictions. But it needs a goal, something to drive to. So this is going to say keep driving, and I need until something happens. So I'm going to put this inside a loop. I'm going to click on the orange menu. I'm going to drag up a loop, and I'm going to put my keep driving inside it. Now at the end of that loop, this is a conditional statement. So it says keep driving until. I'm going to tap on this unlimited symbol, and I'm going to say keep driving until the sensor measures in centimeters. And you'll notice that this block has changed now. So it's going to read, keep driving until it detects something less than, and it says 50 at the moment, but I'm just going to make that 15 centimeters. So once it detects an object inside 15 centimeters, I need those motors to stop. So I pull up another move steering and set it to off. That will stop the motors from moving. The next thing I need to do is then I need to get that head to look left and look right. So I'm just going to drag out my medium motor now, and I'm going to attach it here, and I'm going to slow down the speed to maybe 20. And I know from past experience that I need it to turn 0.27 of a turn. When you talk from a maths point of view, you're looking at decimal numbers. We'll also bring in negative numbers too. So these are really great ways to incorporate coding into a direct math lesson when you're talking about number.
But to add another layer of challenge to this as well, you talked about gear ratios earlier, didn't you, as well? So we can even go one step further again when we go down that engineering kind of rabbit hole and talk about the ratio of gears.
Absolutely.
So that's
0.27 of a rotation.
Yeah, but that's at the motor.
Yes.
Now what happens if you've got a 2-to-1 reduction in your gears, right?
Yeah.
Then you've got more maths to do again, don't you?
Yeah, you need to be able to calculate that to build that into your prototype.
Right, and you can start to see the engineering really coming into the fray with this kit, can't you?
Oh, so much engineering you can build into this. So once the robot has moved its head left, it needs to measure that distance. So I need a variable, much like what Adam had in his Spike program, but it looks a lot different in this program. So I'm going to click on the red menu, and I need to drag in, and I'm going to pop up this at the start, because I'm just going to tell the program, hey, I've got a variable I'd like to use. And I'm going to click here on the variable name, and I'm going to call this one measure left, and hit OK. And I'm just going to initialize a second one, and I'm going to make another variable. This one's going to be called measure right. And so what I need to do, once it looks left, I click on the yellow menu, and there's lots of buttons, but you can hopefully rewind this and watch it again later. And I drag out the ultrasonic sensor. That tells the program, hey, go grab that ultrasonic sensor, look left, and measure the distance. So I need to go back to the red menu again and pull in my variable block. I'll just move this over a little bit, might zoom out a fraction. And I can click and drag and drop this into my variable block. So now what it's going to do, I'll do that again. Oh, I need to set my, it is on right, which is good, write it to a number. And I join these two together. So whatever the sensor is, it's going to now save it and remember it in that block.
Right.
Now I need to make the head swivel back the other way. So I'm going to drag in another, not a move steering. I need a medium motor. I'm going to pop it underneath because and I can join these lines together. It's like a little bit like an extension cord here. And I'm going to tell this motor to move also at a speed of 20. But I need to make it move negative 0.54, which is, let me try that again, negative 0.54. So being a negative number, that means it's going to move in the opposite direction. And it's going to do double the span. So it should move it from far left around to far right. Now I need to measure that distance again. So you can see here that this gets a lot more complicated, doesn't it, to be able to code that?
Yeah, it does, but I think we're doing this in a really compressed time for everyone that's watching this PL session. So
absolutely.
we may seem to be rocketing through this, but if you had the time in your class to teach this over, say, a number of lessons,
series of weeks, yeah.
Oh man, I think you could unpack this into manageable concepts that students could understand, right? And then you could build prototypes along the way. You could test out your ideas. See all those decimal numbers and things that you're touching on there? I mean, we know they work, but what you would do ideally with students is you would ask the question, right? Wouldn't you? Well, what kind of number is required? What kind of rotation is going to achieve that desired output? And then you would do some prototyping. And it's all about that process.
Yeah. Normally when I would code this, because I've practiced this one before, but I would get just that distance sensor to work first and make sure that's perfect. And then I would go back and I would then get the head to move left and right perfectly. Okay, good, I've got that. Then I would measure the distance. So it's a series of iterations within your design process. What I might do, rather than, just because I know we're a little bit limited on time, I'm just going to jump over to the completed program and explain the blocks that I did to finish that off. So you can see here on my screen now that the head has moved left, it measured the distance. It moved all the way around to right, measured that distance. And then I got it to move back to the middle again. So when I do move forward, it can do that left-right sweep again. And then lucky last down here at the bottom, I had to say, get my I had to get my two variables, my measure left and my measure right, and I used this called a comparison block, which I found here under the red menu. You'll find it if I scroll across. It's got a greater than, a less than, this one here, a compare block. And I compared my two variables, and then all I got it to say is if one was bigger than the other. So if the left distance was greater than the right distance, then you would turn away from the closer object, if that makes sense. So I think let's, with the time left, let's quickly test this out.
Oh, I'm excited to see this machine in operation, Jarrod, because
Right.
I've been watching this thing sitting on the table, waiting idly to be, switched on and run.
Yeah.
And I want to see it work in practice.
That's it. So there's a good chance this might drive off the table because we are working in a very small space here.
Oh, I'm excited for that too.
We'll need some objects. Let's get some objects here on the table. So when he sees this box, hopefully, perhaps we will use, let's see. Can you hold that there for me, Adam?
Absolutely.
Hopefully he'll get to here. He'll look left. He'll look right. He'll see this object and turn away from it. That's the plan.
And you'll catch him before he flies off the table,
I will try and
won't you?
catch him. Otherwise, there could be some tears.
Well, it's Lego after all,
That is, and we
right?
just rebuild it. All right, so I'm going to hit go on my code. He sees the object, he looks left and right, and I got him to turn the wrong way, didn't I? So straight away I can see there's a slight issue in my code, so all I need to do, he did almost all of what I want him to do. He looked left and he looked right and he made a decision, but I would need to switch my turns around. So really quickly back in my code, I'm going to make this turn a minus turn and this turn a positive turn, and as simple as that. Test it one more time really fast. Actually, I don't even need to go back that far. Hit go, and fingers crossed he turns the right way this time. Look left, look right, and there we go. And off he goes.
Off he goes.
He looks left and right again, and he makes an informed decision about the best way to turn.
Now, you use the Bluetooth connection to download that, I noticed.
I did use a Bluetooth connection too.
Yes.
What I like about doing that is that every time you make a change, you don't have to plug it in, download it again.
Yeah, and look, just because I said I would do this as well, speaking of connections to the robot,
Yes.
I just want to show you my screen again one more time really quickly for everybody so that we can explain how you actually download that code.
Yes.
Because that was a crucial step that I missed out on the Spike Prime. So kind of important information, Jarrod. So if you just take a look back at my screen again, you will see down in the bottom right-hand side there, you literally have this play button. And that's all you need with the Spike Prime. So you can download it over the cable. It's the quickest, most effective way to do it really rapidly with the Spike. But yeah, that's how you download that code. You can also actually click here and stream your code also with the streaming mode, which means it will update and run it on the fly as you're coding, which is pretty cool as well.
Pretty cool as well.
All right.
All right, to wrap this up, let's just do a really quick comparison between our three different types. I'll throw this slide up here. So you can see on the screen the three most basic, the biggest difference, I guess, is the coding, the number of ports and the number of sensors that we have in these three different kits. So they're all got their different benefits and aimed at different levels, but they're three great products.
Yeah.
And super great to use in the classroom.
They really are. That's the key here. It doesn't matter about the product, is it? Does it belong in the classroom and at what level is it pitched?
Yeah.
And we've hopefully highlighted for you today that there's certainly a good ecosystem there with a low on-ramp and a very high ceiling for students. And, hopefully you'll use this video to make some informed decisions about what works well for you.
And robots are far more than a toy. It's very much a learning tool that you can use in the classroom.
All right, so it is time for some Q&A. So we hope that you will join us for that as well and stick around and ask us some questions about Lego.
We'd love to help you out.